Okay guys, we're going to do these fluid problems part 3. These are slightly more difficult buoyancy problems than we did last time. They involve something called apparent weight, which I'll talk about now. All right, when we talk about the apparent weight of something, we're talking about that the object weighs less when it's in water, even though it has the same amount of mass, because the buoyant force pushes up on it. If you put a scale on it, the scale would read less if you put it in the fluid. And the amount it reads less is equal to the buoyant force acting on it. So if we look at the equation for apparent weight, we'll call it Fa, equals the force of gravity acting on an object minus the buoyant force acting on it. So if the buoyant force is greater than the force of gravity, that means the object would be moving up through the water. So if the apparent weight is negative, that means the object is moving up through the water. If it's positive and force of gravity is larger, that means it's falling slowly through the water. All right, number 1 says, a piece of wood with a mass of 8.71 kilograms is placed in fresh water, density 1,000 kilograms per meter cubed. What is the density of the wood if it has an apparent weight of negative 5.77 newtons? That negative 5.77 newtons means that its density is going to be less than water, because if we pushed it under the water, that means it would float back up to the surface. So the first thing we're going to find here is the force of gravity acting on the wood. So force of gravity on the wood is just going to be mass times gravity. So the mass of the wood is 8.71 times 9.8, and we should get 85.4 newtons. Next thing we're going to do is find the buoyant force that's required to get this negative 5.77 newtons. So you're going to say the buoyant force, the apparent weight is equal to the force of gravity minus the buoyant force. So we get negative 5.77 equals force of gravity, which is 85.4, minus the buoyant force. And that means the buoyant force is going to be equal to 91.1 newtons. Now we're going to use the buoyant force equation to find the volume of the piece of wood. So we say FB equals rho Vg. Density of the, remember density here is the fluid density, so the density of the fluid displaced. So that's 1,000. And again, this is the volume of the fluid displaced, but it's going to be equal to the volume of the wood since it's completely submerged, times 9.8. And that, so that equal the buoyant force of 91.1. Therefore, the volume equals 9.23 times 10 to the negative third meters cubed. So our last step here is to find the density. So we're just going to use regular density, which is the same as fluid density, but density equals mass over volume. So our mass of the piece of wood was 8.71 over the volume of the piece of wood, which we just found to be 9.29 times 10 to the negative third. There should be a 9 right here, not a 3. Sorry about that. And that ends up equaling 938 kilograms per meter cubed. On the answer sheet, this one has an incorrect answer because they assume that the wood was sinking and that negative 5.77 was going down. So if you look at the answer sheet in the back, it's going to be off by a little bit, but this is how to do it. Right, next problem. Number 2 says, a ball with a density of 0.96 grams per centimeter cubed and a volume of 1.1 times 10 to the 4th centimeters cubed is placed in a fluid with a density of 0.86 grams per centimeter cubed. Does the ball sink or float? If the ball floats, calculate the volume of the displaced fluid. If the ball sinks, calculate the magnitude of the apparent weight of the ball. All right, so we know this sinks because the ball is denser than the fluid it is in. So the ball's density is 0.96, the fluid's density is 0.86, so we know it's going to sink. So the first thing we're going to figure out is the mass of the ball based on its density and volume. So we're going to say density equals mass over volume. Density is 0.960 equals m over 1.1 times 10 to the fourth centimeters cubed. And we have centimeters cubed for both our density and our volume. So we'll get grams because it's grams per centimeter cubed. So we know our mass is equal to 10,560 grams, or 10.56 kilograms when we divide that by 1,000. Now we want to figure out the force of gravity acting on the ball. We're going to say force of gravity equals mass times gravity, so 10.56 times 9.8. And the force of gravity is 103.5 newtons. Next, we want to convert the volume of the ball to meters cubed instead of centimeters cubed. So to do that, our new volume is going to equal 1.1 times 10 to the fourth centimeters cubed. And then we're going to multiply that by 1 meter and 100 centimeters. And since it's cubed, you have to cube that, so we do that 3 times, and we get 0.011 meters cubed. And our last step, or second to last step here, is to find the buoyant force. So the buoyant force in this ball when it's below the surface of the water is equal to rho VG. Density of the fluid is, we got to convert that to kilograms per meters cubed, which is just multiplying by 1,000, so it's going to be 860 for the density. Volume we just found is 0.011, and gravity is still 9.8. So our buoyant force here is equal to 92.7 newtons. And our last step, to find the apparent weight. So FA, the apparent weight, equals FG minus FB. So our force of gravity is 103.5 minus 92.7 for our buoyant force, and that equals, for our apparent weight, it's 10.8 newtons. All right, and that's our answer for that one. So one more problem to do. That's number 3. Number 3 says a submersible with mass of 2.78 times 10 to the third kilograms remains at constant depth beneath the surface of the ocean. To make the submersible rise, 1.97 times 10 to the second kilograms of ballast is released. Ignoring friction, what is the upward acceleration of the submarine? So just to make sure everybody understands what's going on, the submarine is releasing a weight in terms of the ballast to float back up to the surface. We talk about a ballast, it's usually water being released and air taking its place to lower the mass of the submarine so it goes back up to the surface. All right, our first step here is we want to figure out the force of gravity acting on the submarine. So it's going to be the force of gravity on the submarine is mass, which is 2,780 kilograms times 9.8. That the force of gravity equals 27,244 newtons. That is equal to the buoyant force here, and we know that because the submersible is remaining at constant depth. So if it's not going up or down, that means the force of gravity has to be equal to the buoyant force. So next what we're going to do is find the new mass. And so to find the new mass, it's going to be 2780 minus 197. And that equals 2583 kilograms. So now we're going to find the new force of gravity after the ballast is released. It's still going to be mass times gravity, so it's 2583 times 9.8, and that ends up equaling 25,313 newtons. So now we can use that to find the apparent weight. So the apparent weight is going to be the total force acting on it here. So it's going to be Fg minus Fb. Fg is now 25,313. I will subtract the buoyant force, which is still this number up here. The volume of the submarine hasn't changed, so the buoyant force stays the same even after the ballast is released. So 27,244 newtons. And that means our apparent weight is negative 1,903.6 newtons. So that means there is a force of 1,903.6 newtons pushing it up toward the surface. So now to find the acceleration, we just do F equals ma, and it's going to be, our force pushing it up is 1,903.6. I'm just going to make that positive because it's going up toward the surface of the water, equals that times the mass, and we're going to use our new mass here, so the 2583, and multiply that by, and find A. So there, A equals, and that ends up equaling 0.75 meters per second toward the surface, or meters per second squared toward the surface. And again, and I messed something up here, I just noticed, guys. This should be 930 instead of 03. I fixed that for this answer, though. Alright, that's the end. I'd like you to do the rest of the problems on the problem sheet on your own. Feel free to email me any questions about those. We will have a group quiz after we do some more problems on Wednesday. Other than that, feel free to email me any questions you have. Thanks. Bye.